Okay. Okay, good day. We're actually trying to experiment how to use or how to go live or how to live stream using YouTube. So I have here now the source code of our binary search. So again, let's try to go over the code. So in this part, we actually declared a linear array and we have here the elements of the array. So as you can see, we have 10 elements, and again, in a binary search, so this would be binary search. In the binary search, the element should be sorted. So in this case, it is sorted from lowest to highest. And then we have here some variables that will be used for the program. First, we have n, or the number of elements. So since our array has 10 elements, so n here is equal to 10. Then L here represents the leftmost index. So we have here L equal to 0, and R here is our rightmost index. So R is equal to n minus 1. So again, this is from 0 up to 9. So there are 10 elements because again, the first index starts with 0. That's why our rightmost index is n minus 1. And then the middle index, so as we have learned last time that for binary search, we have to get the middle index and compare the item to the element of whatever is in that index, the middle index. So we have here our found plug. So it is 0 if it's not yet found, and 1 when the element is already found. And in this case, we already have here hard-coded the item that will be searched inside the array. So here is now the main code for the algorithm, the binary search algorithm. So we have here our loop, the while loop, which ends in this block. So this is the end of the block. So from this up to this, so everything inside will be repeated while found, not found, or that means if found is 0, then not 0 becomes true. So while not found, and L is lesser or equal to R. Again, this is an indicator that there's still a possibility that the item we're looking for is inside the array. But once this becomes false, or that means that R becomes lesser than L or L becomes greater than R, then that means that it is already impossible for the item to be inside the array. So what are the things that we do in a binary search? The first thing we do is to get the middle index. So M is equal to L plus R. So we add and then we divide it by 2. Again, the fraction will be ignored because M here is declared as an integer. So once we know the middle index, all we have to do now is to compare the item with the element at that particular location or at the middle index. So we're going to compare if the item is equal to that element. If they are equal, then our search is now successful. So we change the value found because again, found is our indicator. So if you still remember, it says here that plug is 0 when it is not yet found, and we're going to place 1 if the element is already found. So in this case, if these are equal or the item is equal to the middle index, then it is already found. So if not, then we compare if the item is greater than the middle value. If it is greater, okay, so M here initially is 4. This is part. If it is greater, then that means that it is impossible for us to see the item in this location or on the left side of the array, because again, this is sorted. So if the item is greater than this, then the possibility is the element we're looking for is on the right side. So this becomes our subarray. So since this is our middle, this portion will now become our new left index. That's why if you're going to look at the code, if the item is greater than whatever is in the middle, then again, can be in the upper portion. So change the leftmost index to the index after the middle index. So we just add 1 to the middle index, and that becomes our new left index. But what if the item is lesser? So we're just going to do the reverse. So what we're going to change now is not the left index, but the right index. So again, if it is lesser, then that means it is on the left side. The item can be on the left side of the array. So we do this repeatedly until this condition here becomes false. That means found becomes 1, or maybe L becomes greater than R. Okay, so that's the only time this loop will exit. So once it exits, we have here some sort of a feedback. So we're going to determine if it is found or not. So if found is equal to 1, then that means found is equal to 1, then that means that we have found the item. So in this program, we actually displayed the item and the position. So the item is represented by, of course, item, and the position is, of course, at the middle M. However, if, for example, our program exits this loop because our left is already higher than R, then it did not pass to this one, so the value found was not changed. So initially, again, it is 0. If it is not changed, then that means it was not, the success was not, or the search rather was not successful. So in that case, we printed a feedback saying that the item was not found inside the search. However, we can make some changes with our program. Let's first execute the program. So to execute the program, we just click on execute and then compile and run. Here it's running. There. So item 20 is found at position number 6. So that is our output. Okay, because again, 20 is inside the array. And we have seen that in our source code. So let's review our source code again. So it's at position number 6. So 0, 1, 2, 3, 4, 5, 6. Now we can make some changes with the program, because in our program we have hard coded the volume item. So let's try to change this one. Let's just place here first 0, and then so let's make it more interactive. So we have here our prompt. So how do we read input? We use scanf, and then the format, %B, and then the address. So ampersand item. So in that case, we will be entering the volume item rather than hard coding the I can't see my keyboard there. So rather than we're going to enter the volume item rather than hard coding the value. So let's try the program again. Execute, compile and run. So please enter So let's say for this example, we're going to search for the number 10. If you still remember, actually we have a 10 in our array. So it says here item 10 is found at position number 2. So because again 0, 1, 2. So 10 is, well, let's try to place a number that is not found. Let's say 23. Let's write the number 23. So let's try 23. So item 23 was not found inside the array because we don't have a 23. So maybe some of the variations you can have here is, what if you first enter the values of the linear array, but if you're going to do that, you have to place you have to sort the elements after entering the values, because again, binary search will only work if the array or the elements of the array is actually sorted. Okay, so that is actually the source code for binary search, and let us first end this video for now.